Hello, ladies and gentlemen. This is now again Smart Society and AI, and we start with the topic for week 5. Let's see what are the topics this time. Defining data analysis. So we talk about data analysis, understanding why data is important, and reconsidering also the value of the data. Then we continue with machine learning, the reasons for machine learning and the use of machine learning. So we define machine learning and then go with the topic how machine learning actually works and the benefits we see, and specifying the limits of machine learning today. Also, we will continue with the point how actually machines learn. So learn from data, and there are 3 different ways: the supervised learning, the unsupervised learning, and reinforcement learning. Let's continue then with the first topic, and let's also read this. Okay, so collecting data isn't a modern phenomenon, although the way we collect it at scale is relatively new. People have recorded data in various forms for centuries, regardless of whether the information was in text or numeric format. People have always appreciated how data describes the surroundings world, and among other things, they used it to move civilization forward. Data has an inherent value. By using its content, humanity can learn, transmit critical information, avoiding the need to reinvent the wheel again and again, and effectively act in the world. In this chapter, we will discuss how data also contains more than just surface level information. If data is in a suitable numerical form, you can apply special techniques devised by mathematicians and statisticians known as data analysis techniques to extract even more insight from it. We also show how, starting from a simple data analysis, you can extract meaningful information and subject data to more advanced analytics using machine learning algorithms capable of predicting the future, classifying information, and effectively helping in making optimal decisions. Now let's see this part in Korean as well before continuing. Okay, give me a second please, so that I organize this in a way that we can also see it in Korean. Alright. 데이터가 적절한 숫자 형태인 경우 수학자와 통계학자가 고안한 특수한 기법, 이렇게 데이터 분석 기법이라고 함을 적용해서 더 많은 인사이트를 추출할 수 있습니다. 또한 간단한 데이터 분석에서 시작하여 의미 있는 정보를 추출하고 데이터를 대상으로 더 많은 미래를 예측하고 정보를 분류하며 제적의 의사결정을 효과적으로 지원할 수 있는 머신러닝 알고리즘을 사용한 고급 분석에 대해서도 설명합니다. Now, data analysis and machine learning enable people to push data usage beyond its previous limits to develop smarter AI systems. And this chapter introduces you to the data analysis, which serves not as a lesser solution compared to generative or conversational AI, but instead forms its very foundation. You find out how to use data as a learning tool and a starting point for solving complex AI problems, such as suggesting the right product to a customer, understanding spoken language, translating English into German or Korean, automating car driving, and alike. So let's start with defining data analysis. The process of inspecting, cleansing, transforming, and interpreting data to discover useful information, draw a conclusion, and support decision making. Now, the current era is called the information age, not simply because we humans have become so data rich, but also because society has reached a certain maturity in analyzing and extracting information from that data, with artificial intelligence, so AI, and machine learning, so ML, increasingly playing an important role. Companies such as Alphabet, Google, so Amazon, Apple, Facebook, Netflix, and Microsoft have built their businesses on data and now are ranked among the most valuable companies in the world because they don't simply gather and keep stored data that's provided by their digital processes. All these companies also know how to make data as valuable as oil by employing precise and elaborate data analysis. Google, for instance, records data from the web and from its own search engine, among other sources, and based on the data, it has built a plurality of ML models that are continuously updated to support its business. Let's see a picture about this also. But actually, how much data is available, for example, in Korea? Well, as said, it was like 5%, very low in 2019. We don't know right now. We can assume it's much more than before. Okay, so in 2006, Humbly also emphasized that data isn't just money that rains from the sky. It requires effort to make it useful, just as you cannot immediately use unrefined oil because it has to be changed into something else by chemical processes that turns it into gas, plastics, or other chemicals. So data must also undergo specific and significant transformations to be able to acquire useful information and value. The most basic data transformations are provided by data analyzers, and you liken them to the basic chemical transformations that oil undergoes in a refinery before becoming valuable fuel or plastic products. Using just data analysis, you can lay down the foundation for more advanced data analysis processes that you can apply to data. Data analysis refers to a large body of possible data operations, sometimes specific to certain industries or tasks. You can categorize all these transformations into 4 large and general families that provide an idea of what happens in data analysis. So, transformation first. Transformation changes the data structure. The term transforming refers to different processes, though the most common is putting the data into ordered rows and columns in a matrix format or also table format. The remaining part you can read by yourself, and in Korean as well. I tried to explain. 데이터 전환, 데이터의 구조를 전환하는 것이다. 전환이라는 용어는 다양한 프로세스를 의미하지만 가장 일반적인 것은 데이터를 행과 열이 정렬된 매트릭스 형식, 플랫 파일 변환이라고도 하므로 넣는 것이다. 예를 들어 슈퍼마켓에서 구매한 상품 데이터를 효과적으로 처리하려면 각 고객 정보를 별도의 행에 배치하고 해당 행 내 열의 고객이 구매한 각 상품을 나열해야 합니다. 알고리즘은 각 항목을 개별적으로 분석하므로 한 고객에 대한 모든 관련 정보를 한 행에 포함시키는 것이 중요합니다. 이러한 제품은 수량이나 금액이 포함된 숫자 항목으로 추가합니다. 변환에는 아니면 전환에는 데이터의 평균과 분산 숫자의 계열 평균을 중심으로 분산되는 방식을 변경하는 배율 및 이동과 같은 숫자를 연산도 포함될 수 있습니다. 이러한 조정을 통해 데이터가 머신러닝 및 딥러닝 알고리즘과 호환되도록 만들 수 있습니다. 계속해서 이제 클린징에 대한 이야기 한번 같이 봅시다. Now, data cleansing fixes imperfect data. Depending on the source of the data, you may find various problems because of missing information. So, for example, if you have a table, you could get this table, and you should get some dummy values inside so that the table is completed and can be used by as a machine learning in the future. Now, in Korean, 데이터 정리 불완전한 데이터를 수정해야 합니다. 데이터의 출처에 따라 누락된 정보, 극단적인 범위 또는 단순히 잘못된 값으로 인해 다양한 문제를 발견할 수 있습니다. 예를 들어 슈퍼마켓의 데이터는 상품의 잘못된 가격이 표시되어 있을 때 오류가 발생할 수 있습니다. 일부 데이터는 분석을 망칠 수 있도록 만들어졌음을 의미합니다. 예를 들어 인터넷의 제품의 순위를 변경하는 가짜 리뷰가 거짓말, 그렇죠? 가짜 리뷰가 있을 수 있습니다. 클렌징은 데이터에서 적대적인 사례를 제거하고 신뢰할 수 있는 결론을 내리는 데 도움이 됩니다. 계속해서 이제 inspecting에 대한 이야기 합시다. Validates the data. Data analysis is mainly a human job through software plays a big role. Humans can easily recognize the patterns and spot the strange data element. For this reason, data analysis produces many data statistics and provides useful and insightful visualization. 이제 한국말로도 데이터 검사, 데이터의 유효성을 검사합니다. 데이터 분석은 주로 사람이 하는 일이지만 소프트웨어도 큰 역할을 할 수 있습니다. 사람은 패턴을 쉽게 인식하고 이상한 데이터 요소를 발견할 수 있습니다. 이러한 이유로 데이터 분석은 많은 데이터 통계를 생성하고 유용하고 통찰력 있는 시각화를 제공할 수 있습니다. And now continue with modeling. Modeling is about grasping the relationship between the elements present in a data. To perform this task, you need tools taken from statistics such as correlations, chi-square tests, linear or logistic regression, and many others that can reveal whether some value truly are different from others or just related. For instance, when analyzing expenditures in a supermarket, you can determine that people buying diapers also tend to buy beer. Statistical analysis finds these two products associated many times in the same basket. 기저귀 사는 사람들 그래서 맥주도 산다는 말이에요. Okay, and now data analysis isn't actually a magic. You perform transformations, cleansing, inspecting, visualizations, and modeling by using math, summation, and multiplication based on matrix calculus, which is nothing more than the long sequences of summation and multiplication that many people learn actually also in the school. So the data analysis arsenal also provides basic statistical tools such as mean and variance that describe data distribution, or sophisticated tools such as correlation and linear regression analysis that reveal whether you can relate events or phenomena to one another based on the evidence, for example, as we mentioned, buying diapers and beer. What sometimes complicates data analysis is the vast volume of data that requires special computing tools and computing powers, such as Hadoop. Hadoop is one of the interesting computing tools, and the other one is Apache Spark. So these are two software tools are used to perform massive data operations on multiple computers. So not a single computer, but a lot of computers together. Despite such advanced tools, it's still a matter of perspiration to manually prepare your data. Let's see why actually data is so important. So data analysis is essential to AI. In fact, no modern AI is possible without visualizing, cleansing, transforming, and modeling data before. Advanced algorithms such as machine learning, natural language processing, computer vision, or generative AI enter the process and turn it into information of even higher value than before. In the beginning, when AI consisted of purely algorithmic solutions and expert systems, scientists and experts carefully prepared the data to feed them. Therefore, if someone wanted to develop an algorithm to process information, a data expert would place the correct data into lists, ordered sequences of data elements, just as I mentioned, so basically like tables, pyo in Korean, or in any other structured data format, so a data structure that could appropriately contain the information and allow its desired manipulation. At such a time, data experts gathered and organized the data so that its content and form were exactly as expected, and crafting new data for the purpose required a lot of time and energy. Consequently, algorithms had to work with less information than it is available today. Attention has now shifted from data production to data preparation through data analysis. The idea is that the various sources already produce data in such a large quantity that you can find what you need without having to create special data for the task. More data also makes more algorithms smarter than before. Imagine wanting an AI based on computer vision to control your pet door to let cats and dogs in but keep other animals out. Modern AI algorithms learn from task-specific data, which means processing many images showing examples of dogs, cats, and other animals. Such a huge set of images would come from the internet, usually from social media platforms or image searchings. Previously, accomplishing a similar task meant that algorithms would use just a few specific data inputs selected because they did a good job of illustrating shapes, sizes, and distinctive characteristics of the animals. However, the scarcity of data once restricted the algorithms to only a few specific tasks. Remarkably, there are no examples of AI systems that could power a pet door using traditional algorithms or expert systems. Today, however, there are several working solutions using the latest deep learning algorithms for such and action. Data analysis comes to the rescue of model algorithms by removing bad examples and transforming it according to requirements, which provides further useful information. Now let's see reconsidering the value of data. With the explosion of data availability on digital devices, data assumes new nuances of value and usefulness beyond its initial scope of teaching and transmitting knowledge. The abundance of data provided to data analyzers and complex algorithms allows for new descriptive and predictive functions beyond more reporting. That is, for example, data describes the world better because it presents a wide variety of facts and in more detail by providing nuances for each fact. Let's see this in Korean as well. So, 데이터는 다양한 사실을 제시하기 때문에 세상을 더 잘 설명할 수 있습니다. 사실과 각 사실에 대한 뉘앙스를 제공함으로써 더 자세히 설명할 수 있습니다. So data has become so abundant that it covers actually every kind of aspect of life. And now data shows also how facts are associated with events. Given enough data to dig out the underlying general rules, you can predict how the world will change or transform over time. So once again, in Korean, this here data shows how facts. 데이터는 사실과 이벤트가 어떻게 연관되어 있는지 보여줍니다. Now let's continue. So large amounts of scientific data, for example, from physics, chemistry, or biology, can allow scientists to approach problems without hypotheses, instead analyzing the information found in the data and using intelligent algorithms. This contrasts with the past, when scientists relied on uncountable observations and a multitude of experiments to gather enough evidence to describe the physics of the universe using this scientific method. However, this new data-driven approach to science would merely complement and not replace the scientific method that has been proven so effective in allowing scientists to find many underlying laws of the world. So the ability to innovate using data and AI algorithms is a breakthrough in the scientific quest to understand the world as well. For many other scientists or scientific tasks, data analysis pairs observations expressed as inputs and outputs. This technique makes it possible to predict how things work and to define, thanks to ML, approximate rules, so laws, general laws of our world without having to resort to using long observations and experimentations. Many aspects of the scientific process can now become faster and more automatic using data and AI algorithms. Now, pinnacle or the high point of data analysis is machine learning. You can successfully apply machine learning only after data analysis provides correctly prepared input. However, only machine learning can associate a series of outputs and inputs, as well as determine the working rules behind the output in an effective way. Data analysis concentrates on understanding and manipulating the data so that it can become more useful and provide insights into the world, whereas machine learning strictly focuses on taking inputs from data and elaborating a working internal representation of the world that you can use for practical purposes. Machine learning enables people to perform activities such as forecasting the future, classifying things in a meaningful way, and determining the optimal rational decision in a given context. The central idea behind machine learning is that you can represent reality by using a mathematical function. We talk about this later. Now let's focus on this here, what we have here. So machine learning, a subset of artificial intelligence where algorithms learn patterns from data and make prediction or automate decisions without being explicitly programmed. All right, so here we have feature, focus, and primary use case. So goal itself is data analysis has the goal to understand trends and insights with the focus on interpretation and visualization, and the primary use is business intelligence and reporting. So and data analysis is about this, and machine learning is now about building predictive models and automate decision making process, pattern recognition and automation, and then fraud detection recommendation systems alike. All right. We also see here techniques used. In data analysis, we use descriptive statistics, mean, median, and variance, data cleansing and transformation, just as mentioned before, visualization, so charts, graphs, and dashboards, and hypothesis testing and correlation analysis. Versus, again, machine learning, where we have supervised learning, unsupervised learning, and reinforcement learning, and neural networks and deep learning. Now also key differences in applications. Here you see three different industries, so finance, healthcare, and marketing. And then you see analyzing stock trends. So here data analysis is about analyzing stock trends. And then again, you see here in machine learning, it's about predicting stock prices, and in healthcare, identifying disease trends. So, for example, how fast COVID-19 also mutated, or how fast the cases grew. And then in the case of machine learning, it's about diagnosing diseases using AI. So easier to find cancer, for example, than ever before. And in marketing, customer segmentation is the goal to find, for example, of data analysis, while in machine learning example, we see personalized recommendations based on the data that you provided to the engine, to the computer, how you watched and what you watched during your time, movies and ideas or series or documentaries ever before. So the central idea behind machine learning is that you can represent reality by using mathematical function that the algorithm doesn't know in advance but can guess after seeing some data. You can express reality and all its challenging complexity in terms of unknown mathematical functions that machine learning algorithms find and make actionable. This concept is the core idea for all kinds of machine learning algorithms. Learning in machine learning is purely mathematical, and it ends by associating certain inputs with certain outputs. It has nothing to do with understanding what the algorithm has learned. Data analysis builds understanding to a certain extent. So, the learning process is often described as training because the algorithm is trained to match the correct answer to every question offered the input. Many people are used to the idea that software application starts with writing a function that accepts data as input and that then provides the result. For example, programmer might create a function called AND that accepts two values as inputs, such as 1 and 2, and provides the result, which is then 3. The output of this process is a value. In the past, writing a program meant understanding the function used to manipulate data to create a given result with certain inputs. Machine learning turns this or flips this process around. In this case, you know that you have inputs, such as 1 and 2, and that the desired result is 3. However, you don't know what function to apply to create a desired result. Training provides a learner algorithm with all sorts of examples of the desired inputs and results expected from those inputs. The learner then uses this input to create a function. In other words, training is the process whereby the learner algorithm tailors a function to the data, makes this function to the data. The output is typically a numeric value such as a measure or a probability. Now, to give an idea of what happens if the training process, in the training process, imagine a child learning to distinguish trees from other objects. Before the child can do so in an independent fashion, a teacher represents a child with a certain number of tree images and complete with all the facts that make a tree distinguishable from other objects of the world. Such facts could be features such as the tree's material, so wood, its parts, so trunk, so trunk is the one like this, so branches, right, leaves or needles, and the roots and location planted into the soil. The child produces an idea of what a tree looks like by contrasting the detail of the display of the tree features with the images of the other different objects, such as pieces of furniture that are made of wood but do not share other characteristics with the tree itself. Machine learning classifier works in a very similar way. Under the hood, it defines a mathematical formulation that processes all the given inputs in a way that distinguishes a tree from the other object. First, this process assumes that the existence of a suitable mathematical representation for the task, often referred to as a target function. Next, the algorithm searches to identify or approximate this target function. The ability to identify a variety of mathematical formulations is now the representation capability of a machine learning algorithm. Let's see this one also in Korean. machine learning 본유기도 비슷한 방식으로 작동합니다. machine learning 분류기는 트리를 다른 개체와 구별하는 방식으로 주어진 모든 입력을 처리하는 수학적 공식을 정의합니다. 먼저 이 프로세스는 작업이 적합한 수학적 표현, 혼입 목표 함수라고 하는 수학적 표현이 존재한다고 가정합니다. 다음으로 알고리즘은 이 목표 함수를 식별하거나 근사치를 구하기 위해 검색합니다. 다양한 수학적 공식을 식별하는 능력을 machine learning 알고리즘의 표현 능력이라고 합니다. Now, a target function is assumed to exist for a machine learning algorithm to work, but it may not exist or it may prove unfeasible to find given the circumstances. Making a machine learning algorithm work involves dealing with uncertainty of the results and a certain degree of complexity. In the end, the process of training a machine learning algorithm is much more empirical than theoretical. Let's see also this part a little bit in Korean one more time. So I talk about the target function itself. machine learning 알고리즘이 작동하기 위해서는 목표 함수가 존재한다고 가정하지만 존재하지 않거나 상황을 고려할 때 찾기가 불가능할 수도 있습니다. machine learning 알고리즘을 작동시키려면 결과의 불확실성과 어느 정도의 복잡성을 처리해야 합니다. Okay? Using a mathematical perspective, you can express the representation process in machine learning by using the equivalent term mapping. Mapping happens when you figure out the construction of a function by observing its outputs and associating them with their respective inputs. A successful mapping in machine learning is similar to child internalizing the idea of an object. The child understands the abstract rules derived from the facts of the world in an effective way, so that when the child sees a tree, for example, they immediately recognize it. Such a representation, that is, the abstract rules derived from real-world facts, is possible because the learning algorithm has many internal parameters consisting of vectors and matrices of numeric values. Such parameters equate the algorithm's memory for ideas that are suitable for its mapping activity. So mapping activity that connects features to response classes. The dimensions and the type of internal parameters delimit the type of target functions that an algorithm can learn. During the learning process, an optimization engine in the algorithm changes the parameters from their initial values during learning to represent an approximate target function. Let's see again this one in Korean, because this is a little bit hard even for me to understand. So let's hope that it works fantastically this time. That's it. Now, such a representation. 이러한 표현, 즉 실제 사실에서 파생된 추상적인 규칙은 학습 알고리즘의 숫자 값의 벡터와 행렬로 구성된 많은 내부 매개 변수가 있기 때문에 가능합니다. 이러한 매개 변수는 기능을 응답 클래스에 연결하는 매핑 활동에 적합한 아이디어를 대한 알고리즘의 메모리와 동일합니다. 내부 파라미터에, 이렇게 파라미터는 매개 변수라고도 한다. 크기와 유형 알고리즘이 학습할 수 있는 대상 기능의 유형을 구분합니다. 학습 과정에서 알고리즘의 제적화 엔진은 목표 함수를 표현하거나 근사화하기 위해 학습 중에 매개 변수를 주기 값에서 변경합니다. During optimization, the algorithm searches through possible variants of its parameter combinations until it finds one that allows the most accurate mapping between features and classes. This process evaluates many potential candidate target functions from among those the learning algorithm can generate. The set of all the potential functions that the learning algorithm can discover is the hypothesis space. The resulting classifier with its set parameters is called the hypothesis. A way in ML, so machine learning, to say that the algorithm has set parameters to approximate the target function and is now ready to define the correct classification in any situation. Also, this part, let's see in Korean again. So, during optimization, 지적화 과정에서 알고리즘은 기능과 클래스 간의 가장 정확한 매핑을 사용하는 매개 변수 조합을 찾을 때까지 가능한 변형을 검색합니다. 이 프로세스는 학습 알고리즘이 생성할 수 있는 수많은 잠재적 후보 대상 함수를 평가합니다. 학습 알고리즘이 변경을 할 수 있는 모든 잠재적 함수의 집합을 가설 공간이라고 합니다. 파라미터가 설정된 결과 분류하기를 가설이라고 하며, 머신러닝에서는 알고리즘의 목표 함수를 근사화하기 위해 파라미터를 설정했으며, 이제 새로운 상황에서도 올바른 분류를 정의할 준비가 되었다고 말할 수 있습니다. 이제 다시 영어로 하겠습니다. For an machine learning algorithm to be performing effectively, its hypothesis space must contain a large range of parameter variance, allowing it to fit any unknown target function when solving a classification problem. Different algorithms can have a different hypothesis space. What really matters is that the hypothesis space, you see here as well, contains the target function or suitable approximation, which is a different but similarly working function. You can imagine this phase as the time when a child experiments with many different creative ideas by assembling knowledge and experience in an effort to create a visualization of a tree. Naturally, the parents are involved in this phase and they provide relevant environmental inputs. In machine learning, someone has to provide the right learning algorithms, supply some unlearnable parameters, so hyperparameters, choose a set of examples to learn from, and select the features that accompany the examples. Just as a child cannot always learn alone to distinguish between right and wrong, machine learning needs guidance from human beings to learn effectively, efficiently, and correctly. Now, if you talk about understanding the benefits, you find AI and machine learning used in a great many applications today. The technology works so effectively that often you don't even notice that it is included in the process. Now, in reality, you can find AI used in many ways, including some that you might not immediately associate with an AI. Access control, for example. In many cases, access control is a yes or no proposition. An employee smart card grants access to a resource much like traditional key or keys have done for centuries. Though some locks do offer the capability to set times and dates that access is allowed, such coarse-grained control doesn't answer every need. By using machine learning and deep learning, it becomes possible to ascertain whether an employee should gain access to a resource based on a role and requirement. For example, based on attribute-based access control, so ABAC, powered by a deep learning algorithm, an employee can gain access to a training room when the training reflects an employee's role and needs. The next one is animal protection. The ocean might seem large enough to allow animals and ships to cohabitate without any problems. Yet, it's not the case. Many animals get hit by ships each year, and a machine learning algorithm utilizing sensors and cameras as inputs enables ships to avoid collision with animals by learning the sounds and characteristics of both the animal and the ship as well. The next benefit is, for example, predicting wait times. Most people don't like waiting, right? So, and in healthcare settings, accurately predicting waiting time is very crucial for patients to make informed decisions. Machine learning allows an application to determine waiting times based on staffing levels, workload, complexity of the task or the situation, and problems that the staff is trying to solve, availability of resources, and so forth and so forth. Now let's also talk about the specific limits of machine learning. Currently, it's unclear whether machine learning can provide the sort of AI that the movies present. In reality, as I mentioned before, even the most sophisticated algorithms cannot think, feel, display any forms of self-awareness or exercise free will. What machine learning can do is perform predictive analytics much faster than any human does. As a result, machine learning can help humans work more efficiently when handling vast amounts of information. The present state of AI involves just performing analysis and returning the results. Humans must still consider the implication of that analysis and make the required moral and ethical decisions. This one again in Korean. 머신 러닝은 사람보다 훨씬 바르게 예측 분석을 수행할 수 있습니다. 결과적으로 머신 러닝은 인간이 방대한 양의 정보를 처리할 때보다 효율적으로 작업을 할 수 있도록 도와줄 수 있습니다. 현재 AI 상태는 분석을 수행하고 결과를 반화하는 데 그칩합니다. 인간은 여전히 그 분석의 의미를 고려하고 필요한 도덕적, 윤리적 결정을 내려야 합니다. 머신러닝한테 결정 그 주지 말자. 그건 우리 책임이잖아요. 아직 그래요. 자, 다시 한번 영어로 하겠습니다. The main point of confusion between learning and intelligence is people's assumption that simply because a machine gets better at its job, it automatically displays intelligence and can handle any new task. However, nothing supports this view of machine learning. Similar confusion occurs when people assume that a computer is purposely causing problems for them. The computer can't experience emotions and therefore acts only on the input provided and the instructions contained within an application to process that input. A true AI will eventually emerge when computers can finally emulate the intricate combination of these processes observed also in the nature. Let's see these things here and let's describe them in Korean again. One more time. 다시 한번. 진정한 AI는 결국 컴퓨터가 자연에서 관찰되는 이러한 복잡한 프로세스의 조합을 모방할 수 있을 때 등장할 것입니다. 일단 그러면 유전학 한 세대에서 다음 세대로 느린 형질 적응, 그 다음 학습, 조직화된 소스 및 미조직화된 소스로부터의 바른 학습, 그 다음 탐구, exploration, 의도적인 호기심과 다른 사람과의 상호작용 동한 자발적인 학습, 그리고 creativity, 창의성, 상황에 대한 즉흥적이고 창의적인 대응을 통해 새로운 학습 습득합니다. 오케이. 그러면 계속해서 나머지 봅시다. 영어로 일단. Apart from the fact that ML consists of mathematical functions optimized for a certain purpose, other weaknesses expose the limitations of ML. You need to consider these three important limits. So, limits in representation, overfitting, and lack of effective generalization because of limited data. Now, limits in representation. Representing some problems using mathematical functions isn't easy, especially with complex problems like mimicking human brain. At the moment, machine learning can solve singular, well-defined problems that answer simple questions such as what is it, how much is it, and what comes next. Even the more advanced generative AI applications simply predict the next word or phrase in a sequence based on probability, lacking abstract or symbolic reasoning capabilities. The next, overfitting. Machine learning can seem to learn what you care about, but they actually often don't. So frequently, the internal functions mostly memorize the data without learning any general rules. Overfitting occurs when your algorithm learns too much from the data up to the point of creating functions and rules that actually don't even exist. The next is lack of effective generalization because of limited data. The algorithm learns what you show it. If you show too little data for the task, it won't learn to perform it. If you provide flawed, biased, or weird data, the algorithm will behave in an unexpected and undesired way as well. As for representation, a learning algorithm can tackle various tasks, but not every algorithm is suited for every problem. Some algorithms are adaptable enough to learn to play chess, recognize faces on Facebook, and diagnose cancer in patients. But in others can only handle one task at a time, and they need to forget what they have previously learned before being ready for different activities. The secret to ML, so machine learning, is generalization. The goal is to generalize the output function so that it works on data beyond the training examples. However, the pursuit of generalization introduces new challenges such as overfitting and biased data, where, for example, certain elements are overweighted or overrepresented. Now, imagine the following. The English language has about 170,000 words in current use, although an average adult English speaker typically uses about 20,000 to 35,000 words in their vocabulary. Okay. A limited training dataset of about 5,000 email examples must create a generalized function that can find spam in all the possible combinations of the words. We talked about right now how many. So if you combine them, really, really numerous. You can't even imagine how many. So, which is an astronomical number that far exceeds the capacity of any computer today to calculate. In such conditions, the algorithm trained on such a limited choice of examples will seem to learn the rules of the language, but in reality it won't do well. The algorithm may respond correctly to contexts similar to those used to train it, but it will be clueless in completely new situations. Also, for instance, long before the advent of OpenAI ChatGPT, Microsoft trained its own AI, Tay, to chat with human beings on Twitter and learn from their answers. But we had also very bad examples. So, for example, hate speech, raising concerns about the goodness of any AI powered by machine learning technology. The problem was that the machine learning algorithm was fed bad, unfiltered data. Remember, we have to cleanse the data, etc., etc. If we talk about data analysis, it's still very, very near here. We have to do a few things, not to have biased data, etc., etc. So it's not that easy at the moment to do more than we actually could do. From the point considering how to learn from data, we continue later on during the class time perhaps. And for now, let's quit and let's just take a short look at what we have learned about. So we learned about data analysis, what it is, and why it is important, what kind of categories of transformations are there to transforming, cleansing, and inspecting and modeling. And then we learned how important data is and why analysis is important as well. What the value of data is to be considered, and what the difference between data analysis and machine learning is. After that, we also looked at the data analysis techniques versus the machine learning techniques, and of course we also see here what task data analysis can do and what machine learning can do. And then we continued with machine learning, what it is, and we defined machine learning, and then we went through a few examples and we talked about the limits. So first, here we go. So first about the benefits, so access control, animal protection, and predicting. So many benefiting areas are there, and specifying the limits of machine learning. Okay, Here we learned genetics learning exploration, creativity, and limits of representation, overfitting, lack of active generalization because of limited data we have to deal with. That's it. So thank you very much for your attention, and we finish here. Thank you.